Hello friends, today we will be covering the chapter 1 from the Code AI Plus book of a class 7. So, the number system. Why we need to learn the number system? As you all know, computer do not understand the human language, right? So what computer understand? Computer understand the binary numbers. Binary means 0 or 1. So in the form of a 0 1 only computer understand. So by learning the number system, you will understand how the computer represents the data internally. Okay, and there are different types of number system we'll cover in this chapter: decimal number system, binary number system, octal, and hexadecimal number system, and their conversion as well. So let's begin. Introduction. A computer is a man made electronic machine. It does not understand the language which people use to communicate. Okay, so computer do not understand our language. What it understand? It recognizes only two discrete state, on and off. On off means these are the electronic states. Like when we switch on the button, the state is on. When we switch off it, state is off. So on, how the computer understand? It understand by the this binary digit like a one. So one represent on state, zero represents off state as shown in this diagram. This is because computers are electronic devices powered by electricity, which has only two states, on and off. The two digits 0 and 1 represent these two states in computer. Okay, as I explain you on this. Now we generally use the decimal number system for counting, like a 1, 2, 3, 4, 5, 6. This is whatever the numbers which we learn right from the childhood. That is a decimal number system. But computer do not understand that. A computer uses a binary number system because it understands only two states. Now you will say from keyboard I enter 16 in calculator, right? If I open a calculator, I can do the addition. So how computer understand that? Because those numbers are converted into the binary number system internally. And that's how computer works. Okay, that is called a machine language. But human do not understand all these bits and all these stuffs. So there is some interpreters, all these stuffs are implemented in, okay, in computer. So let's move forward. The binary system is a number system that has just two unique digits, 0 and 1, called bits. So 0 and 1 is called as a bit. A bit is the smallest unit of a data that computer represents. When 8 bits are grouped together as a unit, they form a byte. What does this mean? Like just on next page, it is shown. Okay. So 0, you can see here like 0 1 1 0 0 0. This is a one number. So these are the 8 bits: 1, 2, 3, 4, 5, 6, 7, 8. So this 8 bit form the byte. Okay, we'll see in this in detail. Okay, on next page. Moving forward, number system. Computer is an electronic machine that store data in a coded form or a machine readable form. Therefore, characters have to be represented in the form of electronic pulses. Character, number, everything, symbols, everything. Okay, pulses means what? Two pulses that are used to represent basic numbers 0 and 1 are absence of a pulse means no current means off state. Don't get confused. Okay, and the presence of a pulse means the presence of a current when on state is here, when button is on. Just remember like this. Okay, absence of a pulse represents 0 and a presence of a pulse represents 1. Before going into the detail, it is essential to understand the basic. Okay, before going, moving to the conversion and all those parts. So number system is a way to represent numbers in a computer system. Every value that you are giving to or getting from computer memory has a defined number system. Basically, there are two types of number system: non-positional number system and positional number system. Computer understand only positional. Okay, we'll say this. What do you mean by the positional and non-positional? So non-positional number system. So what do you mean by non-positional number system? In the past, human being counted on fingers. Okay, so if they wanted to do the counting, how they used to do, they do on fingers. For counting beyond 10, they use stones, pebbles, or sticks to indicate values. This method of counting uses an additive approach or a non positional number system. In this system, we have a symbol such as this one stick for one, two sticks for two, three sticks for three, and so on. So, why this is called as a non positional? Because each symbol represented in this non positional system have a same value regardless of a position. What does this mean? Okay, we'll just move on to the whiteboard to understand this. So suppose I am representing the number 3. So I will draw 3 sticks. Okay, so this number is 3, correct? It represents the 3. Now suppose I interchange this. So what it will become? This one only, still it will represent the 3. So it doesn't matter. But if you take an example of the decimal number system, where I have number, suppose 15. Okay, I have 15, so 1 is here and 5 is here. Now if I just change these values, okay, what it become? It will become my 5 will come, and then 1 will come, correct? This one, if I just interchange this. So in place of a 1, I'm writing 5, and in place of a 5, I'm writing 1. Do these two numbers are same? No, these two numbers are different. So if we change the position of the symbols, if we change the position of the symbols, then the value, okay, the value of that particular number is going to change. So our this number system is the non-positional, where the position of the symbols does not affect the value of the final number. And in the decimal number system, our position of the symbol affect the final value of the number. Understood? Super. See, same thing is mentioned here. Okay, same thing. If you read this, you'll understand. Like each symbol represents the same value regardless of its position in a number, and to find the value of the number, one has to count the number of a symbol present in the number. Okay, but in such a number system, it's very difficult to perform arithmetic calculations because the number is going bigger and bigger. Okay, in positional number system, in a positional number system, there are some symbols called as digits. These symbols represent different values depending on the position they occupy in a number. The computer can understand only positional number system. Why it is so? We'll see. Okay. When we type some letters or words, the computer translate them into numbers as it understand only numbers. Because if you type, like you can say, I can write down my name. How computer display it in notepad and all this? Because for every character, every symbol, there is a number assigned to it. Okay, so computer, and in a worldwide that standard is accepted. Okay, so, and that number is internally converted into the binary number system, which computer understand. Okay, so this is how it work. There are four positional number systems. These are decimal number system, binary number system, octal number system, and hexadecimal number system. So we'll see one by one. A decimal number system. The decimal number system is a base 10 number system. Decimal means 10. The base of a number system indicates how many symbols it uses. Base 10 means 10 symbols. So which 10 symbols decimal number system uses? From 0 to 9. Each 0 to 9. Okay, so each of the symbols in the number system has a value associated with it. We have seen the example, right? 15 and a 51. So each one is having some value, each digit. Okay, so we'll take an example. We'll take one example. If you go here, I'm sorry, if you go here, we'll take the 1 2 3, this number. Okay, so The decimal number system is also positional. This means that the numbers such as a 1, 2, 3, each position in the number has a value associated with it. What does it mean? We have seen in the previously as well. We'll take this example 1, 2, 3. So now 1, 2, 3. So this 3 is the at a ones place, 2 at a tens place, and 1 is at a hundreds place. So how this is calculated? Like if I can expand. You have done this in the mathematics, like the expanded format and all those stuffs, right? From I mean in the writing in the tens ones format as well, correct? So it is something expanded format is something like this, like 1 into 100. So this is the 1. 2 into 10 means this 2 we are saying, and 3 into 1 as this is the ones. So what it becomes 100 plus 20 plus 3. What does this mean? 1, 2, 3. So each this digit, like this 1, 2, and 3, it is having value at their position. If I change this, it will change. We have seen this example, correct? Now, how I can write this? Okay, I'll just clear this. Again, I will do. So 1 into 100 plus 2 into 10 plus 3 into 1. So equal to 100 means 10 raised to 2. 10 raised to 1 means 10. And 10 raised to 0 means 1. So you can also write down like this. Okay. So as you go from left to right, go on increasing the power of this 10. If you say this is a 0, this is a 1, this is a 2. If I go on adding, then it will add up that particular place. Okay, so just to understand you, I have written like this. If you go to the book, see, they have shown you the same format. Okay, so this is expanded format is shown so that you can understand the positional number system, why the system is called as a positional. Now binary number system, and this power thing you will get more. I mean, yeah, this will help you in conversion when we will do the conversions from one number system to another. Now binary number system, as I previously discussed, binary is a base 2. What do you mean by base 2? By means 2, so base 2 means it have only two digits. So whatever is a base, though those many symbols that particular number system will use. So the symbols it uses are 0 and 1, just as each position in a decimal number has a place value associated with it. So, same in binary number system. Bits and bytes. We will say what is a bit, what is a byte, what is a nibble. Bit, binary digit. The smallest unit in the computer processing is called a bit. It is a unit of data that can be either of the two conditions. Bit is either 0 or 1, no other value. Okay. Groups of bits make a storage units in a computer called the characters, bytes, words, which are manipulated as a group. What does this mean? Like every number, as we have seen earlier as well, or every character have some number, and then those are getting converted into the binary number system. So the binary number system, it's not like only 0 1. So it is a combination of a bits. Like see, you have seen here 0 1 1 0 0 0 1 0. This is a one number. Now which number is this? We'll see. Okay, we have to convert this into the decimal, then only we will understand exactly which number this is representing. So each of the 0 and 1 in the following diagram indicates a bit. Byte, binary term. A group of a 8-bit is called byte. Evidently, many such groups can be made in the binary system. 2 raised to 8 or 256 bytes are possible, and they can be represent 256 characters. Clearly, these 256 bytes are enough to represent 26 letters of the alphabet, both capital and small forms, numbers from 0 to 9, punctuation marks, currency signs, and some special symbols. What does this mean? Like, this is a maximum number which can be shown using a binary number system. Okay, and 2 raised to 8. Like, we have this, no? So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, Okay, 2 raised to 6, 2 raised to 7 and 2 raised to 8. So 1, 2, 3, 4, 5, 6, 7. This one. Okay. This is the maximum possible. Okay. Now moving forward. So half a byte means byte is a 8 digit, 8 bits, sorry, and nibble is a 4 bits. So this 0110 is a one nibble, 0010 is another nibble. Now moving forward, this portion we will come later. In a binary, the place values moving from right to left are successive powers of 2. What does this mean? When you move from right to left, we'll see first one example and then we'll come to this. Okay, so we'll see like 1001001. This is a one binary number. Now which decimal number this represent? For this, what you need to do, you just need to write the powers of a 2. Okay, what power will come, I will tell you here. One second. 0, then another is a 0, and then 1. Okay, what they said, like from whenever you will move from this to this side, the successive powers of 2. So 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, like this we will add. So what is a 2 raised to 3? It is a 8. What is a 2 raised to 2? It is a 4. What is 2 raised to 1? It is a 2. And what is 2 raised to 0? This is the 1. Now this will be 0, this will be 0, this will be 1. Now do the addition. 8 plus 0 plus 0 plus 1, it is a 9. So this number represent in a decimal 9. Understand? Now just go to the description what they have given. To construct a binary number, place ones in the positions where the corresponding values add up to the quantity you want to represent and place zeros in the other positions. For example, 4-digit binary number, the binary place values are from right to left 1, 2, 4, 8. We have seen binary number 1001. Same example we have taken has a ones in the positions for a values 1 and 8, correct? And zeros in the position 2, 4. So therefore the quantity represented by binary number is 1. So wherever there is a 1, they have directly 8. But you should understand why this 8 came, why 00 is here and why 1 is here. That's why I explain. Okay, I hope you understand. So this is how the binary number is converted to decimal. We'll come to that point as well. It is covered in the next pages. So a bit refers to binary digit in a binary number system. The table given below shows the binary equivalent of some decimal number. So any decimal number you can convert. You can take example of a zero. How what exactly how the zero is represented in binary. One is represented in binary. Two is represented. Three. I'll just show you 3, 4. Okay. So like 0, 0, 0, 1. Okay. So 0 into 2 plus 0 into 2 plus 0 into 2 plus 1 into 2. Sorry, 1 into 2. So this is 0, 1, 2, 3. But as this is multiplied by 0, it will directly come 0. This is also 0, it will come 0. This is also 0, it will come 0. Plus 1 into 2 raised to 0 is a 1. So 0 plus 0 plus 0 plus 1. What is the answer? 1. This is how you can do for other. So just to do a practice for other binary numbers. You will get a confidence as well and you'll come to know like how the 4 is represented, how the 6 is represented. So this is a equivalent for a equivalent binary number for the 6. Now octal number system. In an octal number system, the base is 8. Hence, there are only 8 symbols. As you know, whatever is a base, those mean symbols. What are the 8 symbols? Like a 0, 1, 2, 3, 4, 5, 6, 7. Only till 7 numbers will come in this. Okay, 8 and 9 do not exist. The largest single digit is a 7. Okay, each position in an octal number represents a power of base 8. Okay, for example, the binary representation of a decimal 74. This is now why the 10 is written here. So whenever you represent any number, the base you write at the bottom of the this closing brace. So here 10 is written, so you can understand this is a decimal number. 2 is written here, so this is a binary number, and 8 is written here, so this is not a decimal, though it look like a decimal, but this is the octal number because its base is 8. Understood? Okay, so now the octal number, how it is converted to the decimal, we can say this 112. So same way, you will write a 8, whatever is a base you have to multiply that base and then go on adding the power. Okay, from right to left, start from 0 and go on increasing same way. Okay, how you will do? Same way. So what number we have taken? 112. This is the base 8. So 1 you will add 8 plus 1 you will multiply by 8 and 2 multiply by 8. What we said, like go on adding the powers. Okay, 64, 8 square, 8. Okay, 1, 2. So this is a 74 base 10. Okay, see the answer. Now this way you can do. So the decimal equivalent of a octal 112 is equal to 74. Now since there are only 8 digits in the octal number system, 3 bits are sufficient to represent an octal number in a binary system. So here there is a binary equivalent. So how you can convert the octal number to a binary? This is little bit different. So you know what is the binary equivalent for a 0? It's a 000. For 1, 001. For 2, 010. Correct? So you need to know from 0 to 7 what are a binary equivalent. When you represent octal to binary, what you will do, you will directly write the 3's binary equivalent here. Suppose 37 is a octal, and how you will write a binary conversion? You will write directly 3's binary equivalent and 7's binary equivalent. That's it. Okay, and this is how the binary number will come here. Understood? Super. The conversion, every conversion have some steps. Okay, we will learn those. Now hexadecimal number system. What is a hexadecimal? Hex means 6. The hexadecimal number system uses a 16 digits including 6 letters of alphabets. So 16 digits. We have a digit still 10, correct? I mean 0 to 9, correct? 10 is formed by using a digit 1 and 0. So the 10 digits are from 0 to 9. Then how the 16 symbols? So it uses a letter as well. This includes the hexadecimal number system symbol include 0 to 9 number and A to F letter. For what A stands for, we will see. Primary reasons why the hexadecimal number system is used with the computers are given below. Okay, before going further, further, I'll just tell you what is the A and A to F. So here it is shown, like hexadecimal 0 to 9, and A means 10, B means 11, C means 12, D means 13, and E means 14, and F means 15. Okay, so if you have a hexadecimal number like 1A, so A means what? 10. Understood? A represents 10. So yeah, will come here. Primary reasons why. So it can represent the binary values in a more compact and readable form. And the conversion between the binary and hexadecimal number system is a very efficient. These are the main reasons why you need to understand hexadecimal. As hexadecimal conversion between binary and hexadecimal is a very efficient. An 8 digit binary number can be represented by a 2 digit hexadecimal number. So, okay, for example, the decimal number 79, whose binary representation is this, can be written as a 4f in a hexadecimal. 4f directly. Okay, so suppose I have one ff16. So again, how you will convert this hexadecimal to decimal? Same way, what I told you, whatever is a base, go on writing that base number and add the power from right to left, like 16 raised to 0, 16 raised to 1, 16 raised to 2. Now can you multiply f with 16? F is stand for 15, so just change that, find out a value and go on adding. Okay, I'll not do this calculation, you just do this and verify. The basic for conversion is the same. Okay, thus the decimal equivalent for a hexadecimal number 1ff base 16 is 511 base 10. Since there are only 16 digits in the hexadecimal number system, 4 bits are sufficient to represent any hexadecimal number in binary. So table is given below. How you can do this? Now the hexadecimal number is 4b3a. To convert the hexadecimal to binary, you can directly write down the binary equivalent. Okay. For decimal to binary, we do not do like that. We have to do the conversions. But for octal and hexadecimal to binary, you directly write down the binary equivalents. I hope you understand this. Okay, now one point we have left, which is this one for a binary. If the last digit of a binary number is a 1, the number is a odd. If it is a 0, the number is even. Why this is so? Why this is so? Because if you see 1101, this represent the 30. Okay, this represent 30. And what is its last digit is a 1. Okay, last is 1. So, and this is the odd number. Easily you can see here. See, for a 1, last digit is a 1. For 3, last digit is a 1. For 5, last digit is a 1. For 7, last digit is a 1. For even numbers, last digit is 0. Okay, observe this. Correct? Yeah. So you can just remember that. In the base n representation of the number, no digit exceeds n minus 1. Okay. Uh, So base 10. So how many digits used? 0 to 9. Base 15. Base, sorry, 16. Sorry, slip of tongue. So base 16, 0 to 15. So n minus 1. Correct. Base 8, 0 to 7. So n minus 1. Every digit of base 2 number must be 0 or 1, that we have seen. Okay. So I'll stop here and we'll cover the conversions part into the next video, conversion of a number system. I'll you know um, upload the separate video for this. Thank you for watching. If you have any queries or any questions, you can definitely comment into the comment section.